Yes, now we are going to discuss question number 2 from the topic functions, and this is the class for those who are preparing for IP 2025 examination from Mathematics 1A. Question number 2 you will get from functions topic, and usually from functions topic the second question must be domain and codomain model questions, domain and range model questions usually in the examinations, previous examinations. Let us see first question. Find domain of the function f of x equal to 1 divided by x square minus 5x plus 6. This is the question. F of x is given as 1 by x square minus 5x plus 6, for which you have to find the domain. Domain is nothing but set of values of x satisfying the given function, right? Yes. This is 2 marks question. You have to write f of x is defined if and only if the condition here x square minus 5x plus 6 which is non-zero. Why? Because it is of the form p of x by q of x, that is rational function it is, and denominator should be non-zero. For existency of the function f of x, it is very clear that since due to rational function denominator part must be non-zero quantity, and x square minus 5x plus 6, for which the factors I am going to write x minus 1, this is the question, x square plus 6x, minus 6x plus 5. The question you have like this, x square minus 6x plus 5 is the question, and for which the factors x minus 1, x minus 5, product of roots 5, sum of roots minus x minus 5x gives minus 6x. Okay, so that from this I can write x minus 1 non-zero and x minus 5 non-zero, so that x not 1, x not 5, so that x any real number but not 1 comma 5. This is your answer. Okay, for what values of x the function is defined. The meaning here, domain is nothing but due to rational function denominator part should be non-zero quantity. After factorization you got x minus 1, x minus 5. Since they are non-zero quantities, x not 1 as well as x not 5, that is any real number except 1 comma 5 is your answer. So in this way you have to express. Let us move to the second one. Next question. Second question. There is a special function. Find the domain of f of x which is equal to log of x minus step x. This is the question. Here the function f of x, it is logarithmic function, right? So it is defined if and only if input x minus step x always more than 0. Remember, you know that by the basic definition of logarithmic function, y equal to log x, which is defined for all x more than 0, right? Log x is defined for all x more than 0, so that whatever the input you have to this logarithmic function, that should be greater than 0. Due to that reason x minus step x more than 0 is written. And if and only if x is greater than step x, okay, there are two functions y equal to x, y equal to step x. and here the condition y equal to x is greater than y equal to step x. Let us cross check by the diagram. First function y equal to x I am going to draw. Y equal to x nothing but straight line passing through origin. Next, the graph of y equal to step x. Step x graph like steps you will get in this way. Okay? Right. Observe here the condition, the graph of y equal to x which is more than step x. Here at 0 they coincide, at 1 they coincide, at 2, at x equal to 1 coincide, at x equal to 2 also they coincide, at x equal to minus 1 also they coincide. They are equal, but there is no such condition. X is more than step x is there. Yes, always x is greater, but particularly at integers it is not greater than step x. They are equal, remember. So you have to remove equality. No need equality. Equality I am going to remove. Okay? Why? Because there is no equal sign. Just x more quantity compared to step x quantity. That reason you need to write. So the reason here, x any real number but not integers. For all real values except integers, the condition is true. This is the line y equal to x. Greater than x, there is no function. Step x is below this, and here the same, x is more than step x. So that condition satisfies for all x belongs to real minus integral values. Okay, r minus z you have to write. Why we are removing integers is, when you put integer they are equal. At particularly 0 they are equal. At 1 also equal. At 2 also they are same. But there is no equality. Due to that reason integers are eliminated. Answer r minus z. And one more way to write the solution I will explain. Listen, method 2. X minus step x is nothing but fractional part of x. Okay? You know the graph of fractional part of x. Fractional part of graph you will get in this way. 0, 0, 1, 0. For 2, fractional part 0, minus 1, minus 2. For all integers it is equal to 0. But more than 0 we need, right? No need equality. Remove this. No need equality. Remove this. No need equality. No need equality. No need equality. So we are going to remove integer quantities from the entire real values. So x belongs to any real number but not z. The same answer you got. X minus step x is nothing but fractional part of x. Fractional part values always lies between closer to 0 to open 1. But here step x, fractional part of x should be greater than 0 is given. Equal to 0, just if you remove from this, you will get more than 0 values. So equality holds at particularly integer quantities, so that r minus z is the answer. Okay? Let us go for the next one. Next question, find the domain of the function f of x equal to root over 4x minus x square. 2 marks question. Here the function f of x is defined if and only if internal part 4x minus x square, which is always greater than or equal to 0, remember. Why? Because square root function is defined only when you give input other than negative numbers, including 0 and positive values. Square root of x is defined. So due to that reason, input should be non-negative quantity. Inside the square root, whatever the quantity you have, that is non-negative. root minus 1, root minus 2 in real number system it is not defined. So due to that reason only the positive values as well as 0 you have to use 4x minus x square greater than or equal to 0, and I can write x square minus 4x which is less than or equal to 0. By reversing these two terms you will get change in the inequality, greater than or equal to 0 changes to less than or equal to 0. And now factorization, x into x minus 4 less than or equal to 0. You know that x square minus 4x second degree indicates a parabolic shape diagram, and here the roots are 0, 4. You will get in this way. This is a parabola passing through 0, 4. They are roots of the equation. Okay. X square minus 4x that indicates y equal to x square minus 4x, that is second degree expression that indicates a parabola. Y equal to 0 right hand side, nothing but x axis. Comparing x axis and parabola, here what I am saying, x square minus 4x is parabola and y equal to 0, that is x axis, y equal to x square minus x parabola. Parabola less than or equal to x axis is given. Parabola should be less than x axis. X axis kante takku undali, this portion, right? This portion exists only in the domain in the interval 0 to 4. So that I can write x belongs to 0 to 4. Due to equality you have to put closed bracket, remember. Very important notations. If there is no equal sign then you have to put open brackets. If there is equal symbol then you have to include 0 and 4. Why? Because when you write x value 4, 4 minus 4 equal to 0. When you write x value 0, 0 into something, again it will be 0. So to get 0 we have to use both 0 as well as 4. So in such cases you have to write closed bracket. The meaning here, we are including 0 and 4 as well as in between these two. Okay. So the answer x belongs to closed 0 to 4. And let us find next question. Find the domain of the function f of x equal to the same model, but the question is f of x equal to root over x square minus 25. See the solution. Here the function f of x is defined if and only if x square minus 25 greater than or equal to 0. I am going to factorize this. X plus 5 into x minus 5 greater than or equal to 0. Now clearly second degree expression y equal to x square minus 25 indicates parabola and y equal to 0 indicates x axis. X axis as well as parabola with roots minus 5 and plus 5. Here the condition is parabola should be greater than or equal to straight line. Parabola should be greater than straight line. This portion you need. So for existency of this portion, the values of x must be minus infinite to minus 5 and then 5 to infinite you have to write. So x belongs to minus infinite to minus 5. When you write minus 5 then it becomes 0. Equality holds for minus 5. So that you have to put closed bracket. And for infinite and for minus infinite always you have to put open bracket, remember. And union next another one 5 to infinite. Okay. 5 comma minus 5 included. Why? Because when you write 5 minus 5 becomes 0. So equality holds. By writing x value minus 5 again it is 0. Equality holds. So for equality you have to put closed brackets. Okay. This is domain of the function. Domain is nothing but for what values of x the function is well defined. That is the question. And next another question. Find the domain of f of x equal to 1 by root over 1 minus x square. 1 divided by root over 1 minus x square. Yes, see the solution. Here the function f of x is defined if and only if 1 minus x square should be more than 0, that's all, but non-zero, but not equal to 0, only more than 0. Inside the square root, you know that the quantity always non-negative, but here since square root part which is in denominator part should be non-zero quantity, so it is non-zero, nothing but only more than 0, you have to write. So after this, if I interchange these two terms, you will get less than 0, and factors of this x plus 1 into x minus 1 less than 0. Actually this is parabola y equal to x square minus 1. Y equal to 0 is nothing but x axis. Parabola whose roots minus 1 plus 1, y equal to 0 is nothing but x axis. The condition here, parabola should be less than x axis. Parabola less compared to x axis, this shaded part, and this is exists in the portion minus 1 to 1 itself. Therefore x belongs to minus 1 to 1, and here you have to write open brackets, remember. Why? Because there is no equality. Equality holds only when you write minus 1 1, but the condition equality does not holds for existency of this function, so that no need to write closed brackets minus 1 to 1, you have to write only open brackets, remember. They are very, very important. Based on open intervals and closed intervals, you will get total marks. In case if you write closed brackets, you lost 2 marks, remember. Careful on writing open brackets and closed brackets. Where the equality holds, there you have to put closed bracket, remember. If there is no equality in the condition, just to put open brackets. And one more thing, for infinite and minus infinite, we use generally open intervals only. Okay. So this is about question number 2 in mathematics 1A. So the students, those who are preparing for IP 2025, please concentrate on these type of models which are based on domain of the given function. Okay. So let us crack IP 2025 in successfully this year, and those who are watching this video, please subscribe the channel. Thank you so much.